Hello everyone, this is Steve. I'm delighted you could join me. Let's go ahead and graph this rational function together. This one looks a little bit different than some of the other ones we work with because it's completely factored on top and completely factored on the bottom, and there's only one factor on top and only one factor on the bottom, even though the one on top has multiplicity 2, the one on the bottom has multiplicity 3. This will actually make our jobs go pretty quick. For instance, domain. I can see right away that the bad number to plug in here is negative 2, because if I plug in a negative 2, I'm going to end up dividing by 0. I'm going to go ahead and jump over negative 2. The factors on top and on bottom are not common, so they don't cancel. They won't in Math 121 ever anyway. But that means the one value I kicked out of my domain is also the location of my vertical asymptote, which I do need to write as an equation, x equals negative 2. Horizontal asymptote, you might think it's more difficult to do because it's factored. In this case, it really isn't. Because to find the horizontal asymptote, if there is one, you examine the degree of both the numerator and denominator. And those can actually be found by adding the multiplicities on the factors. And since there is only one factor on top and bottom, their multiplicities are the degree. So we have degree 2 and degree 3. And if you ever have a degree on the bottom larger than the degree on the top is smaller, that means you do have a horizontal asymptote, but there's no math to do. It's just y equals 0 directly on the x-axis. Okay, x-intercept. If there's an x-intercept, we find that by setting the top equal to 0. Because it's nicely factored, we get a couple pieces of information. First of all, we see that the x-intercept is at 1, 0, but we also see it has multiplicity 2, which means we're going to have a bounce on our rational function right at that x-intercept. All right, y-intercept. We have a y-intercept because I didn't kick 0 out of the domain, so I can plug a 0 into the function. If you plug a 0 into this function, you're going to get negative 1 squared on top, and you're going to get 2 cubed on the bottom, or 1/8. So our y-intercept is actually at 0, 1/8, very close to the x-axis, but still there. All right, got my intercepts, got my asymptotes. Let's see if we can draw a graph. Well, we've got the one vertical asymptote at x equals negative 2. One vertical asymptote means our graph's going to be broken up into two different pieces, one on the left of the vertical asymptote and one on the right. We also have a horizontal asymptote right on the x-axis, but we don't call it the x-axis, we call it y equals 0. Okay, we do have a couple ordered pairs. We have the x-intercept at 1, 0, where we're actually going to do a bounce, if you remember. And we have the y-intercept at 0, 1/8, just barely above there. Now, I know because of my y-intercept, and because I only have the one x-intercept, that the graph can't be down here like this, because there's no way I could get to that y-intercept without illegally crossing the x-axis. So I know I'm not drawing my graph down there, so let's get rid of that nasty mess. And I know I'm going to be drawing up here, like this. But when I get to this x-intercept, I am going to bounce off of it, go up, but since I have to eventually hug my horizontal asymptote, I actually come back down. Now it turns out, class, and you'll see this in a moment when I show you the technology graph, that that bounce is so slight that the graph really doesn't go up at all, and it's so hard to see that. So this is exaggerated to show you the bounce. But when we look at the technology one, you really won't be able to see that bounce very well. What's going on the other side? Well, neither one of these pieces breaks the rule of hitting the x-axis illegally, so I'm going to need to plot an extra ordered pairs, because I don't know which one of those is correct. So I go slightly to the left of my vertical asymptote, maybe right here at negative 3, and I plug that into my function, h of negative 3. If I plug that in there, I'll get negative 4 squared on top, and the bottom I'll get negative 1 cubed. So I will get negative 16, which is well below where I actually want to draw my graph. So I'm not really going to plot that actual ordered pair, but what I am going to do is I'm going to use this observation to realize that I am going to be below the x-axis, and then just draw a sketch in. So here it is. And that's my graph. Let's see how I did by checking the technology graph. Well, you can see I do have the asymptotes in the right place, and I do have the curves in the right place, but as I warned you about, that bounce is so slight and it goes above the x-axis so little that you can't even see it here on this graph. So while this is an accurate graph, just you can't see all the key features because we're not zoomed in far enough, I always like our graph better because we can see that bounce there and we can see what actually happens, even though it's exaggerated. So either you make it exaggerated and people can see it, or you make it how it actually looks, but then it's almost invisible. So we kind of lose either way, or we win either way. It's called a win either way. Thanks for watching. I hope that helped.